work. So how can you describe a function? We're going to investigate the function f of x equals 1 over x to the, or 1 over x minus h. So we're going to pick a value between negative 10 and 10. For example, if we chose 7, it's 1 over x minus 7. We get to pick any number we want between negative 10 and 10. Let me get my dock camera open. There we go. Okay. So that's the equation we're looking at. F of x equals 1 over x minus h. And basically we want to, there's a lot of stuff in this textbook, but it says make a table, draw a complete graph. Is there more information? And then fully describe the graph. So that's what we're going to do here. Problem 30 kind of walks us through all of those steps. Does anybody have a favorite number they want us to use? No? Okay. The book said 7, so we can just go ahead and do 7 for ours. So we're going to investigate this function f of x equals 1 over x minus 7. So what we're going to want to do when we make our table here, we're going to want to center it around 7 because that's the h value we chose. So here we did h is equal to 7 to get this equation. We'll do 1 or 2 more to kind of look for patterns. So since it's centered at 7, I'm going to go 5 above and 5 below. So I'm going to count my table. Okay, so basically if I plug in 2, I have 2 minus 7 in my denominator. So I'll just show the steps for this one. So it'd be 1 over 2 minus 7, which is 1 over negative 5. So that's the same as just negative 1/5. Or if you wanted it as a decimal, negative 0.2. So for f of 3, it would be 1 over 3 minus 7. 1 over negative 4 is negative 1/4. Or negative 0.25. So take a minute, try, you don't have to necessarily show all your steps because you'll see kind of a pattern going on. Try to plug in the rest of these numbers to complete your table. I'll give you guys maybe a minute or so to do that. Sorry. So when we plug in 7 in our denominator, we have 0. So 1 over 0 is not allowed. Let me go back to that. So for 7, we have 1 over 0, which D and E, or I don't have much room there, but it does not exist. We're not allowed to divide by 0. So we're going to go ahead and set up a graph. So set up your axes. You're going to want, sorry, I didn't set that up very well. You're going to want to leave some space because X is 7. You're going to need your X axis to go all the way to 12 at least. So I'm going to set mine up closer over here. When X is 2, we're at negative 0.2. X is 3 is negative 0.25, negative 1/3. X is 5 is at negative 1/2. X is 6 is negative 1. And then we skip 7. 7 does not exist. At 8, we're up at 1. And then, so you're just plotting all of these points. They kind of look like that so far. So what we're going to want to do from here is we're going to want to look at what happens as we get closer to 7. So I'm going to make another little table. And let's do like maybe 6.2, 6.4, 6.6, 6.8. So same thing, you're gonna want, you probably need your calculator a little bit more for these ones. So 1 divided by, and then if I use my calculator, 6.2 minus 7, I get negative 1.25. So hopefully you can see that. So I plugged my denominator in parentheses if I wanted to use one step in my calculator. I could have done the denominator separately. 6.2 minus 7 is 0.8, or sorry, negative 0.8, and then 1 divided by negative 0.8. But then we already know 7 does not exist. So go ahead, try to finish filling in that table. So I went ahead, hopefully you were able to get some of these values there. And so if I just kind of focus on this top half, so at 6.2, I'm at negative 1.25. And then so kind of plot these points if you can. 6.4 is negative 1.67. 6.6 is negative 2.5. And 6.8, we're all the way down at negative 5. So as these numbers get closer and closer to 7, we're going to be dividing by a smaller number. And when we divide by a smaller number, we end up with bigger values. Mind you, they're negative here. But what's going to happen is we're never going to get to 7. We won't ever be able to plug 7 in. So this piece of the graph, let me turn my paper a little bit. So that part of your graph looks something kind of like that. And then this half, same thing, I'm going to plot the points on the other side. Okay, so that's kind of what our graph looks like. And so right here we see it's, I'm going to kind of put a dash line in a different color. It never quite reaches 7. 7 does not exist. Also, it'll never kind of, it's hard to see this one, but on this x-axis, I'm putting another dash line because it's never going to be equal to 0. 1 divided by some number can never give us 0. It'll get close to 0, but it'll never be 0. So if we remember, those are what we call asymptotes. So this graph has 2 asymptotes. It has a horizontal asymptote and a vertical asymptote. The vertical asymptote is at x equals 7, and then the horizontal one is at y equals 0. So if x is 7, it's not allowed to happen. And also y is not allowed to be 0. Again, it can't be, x can't be 7 because if we plug in 7, we divide by 0. And y can't be 0 because we'll never get an output of 0 here. We'll never, 1 divided by a number will never give us 0. And we'll learn more about this graph later on. We're just kind of investigating it. So a couple of other things. So x-intercept, where does it cross the x-axis? There is none, because that's where we have our asymptote. Our y-intercept, that's going to be this point right here, which we don't necessarily know what that point is, but we can easily find it. So remember, anytime you want your y-intercept, it's when x equals 0. So if x is equal to 0, we have the point 0, -1/7. -1/7 just comes from plugging a 0 into our denominator. 0 minus 7 gives us -7. Just the same way I was plugging in the numbers here, if we kept going backwards and worked up to 0, we would get that point. Let's see what else we want to, what else did we describe yesterday? Oh, so our domain and our range. Those are gonna go a lot with our asymptotes. So our domain is everything x is allowed to be. What are we allowed to plug in for x? We can plug in any number for x except 7, because when we plug in 7, we divide by 0. So our domain is all real numbers except x doesn't equal 7. And then our range is all of the y values, all of the outputs. It goes down forever, it goes up forever, but it doesn't ever hit 0. So our range is y doesn't equal 0. So you can kind of see here the correlation with the asymptotes in the domain and range. It's not allowed to be those numbers in the domain and range, so that's why we have asymptotes at those points. Okay. So what I want you to do, and you are welcome to use Desmos, and I'm going to give you guys just a few minutes. Pick a number for h. Let me go back here. So what you're going to do is you're going to pick a number for h between -10 and 10. Don't pick 7. Some people need to pick a negative number. So for example, if I did h equals -3, my equation would be f of x equals 1 over x minus -3, which we all know is the same as 1 over x plus 3. So what I want you to do is pick 1 or 2 other numbers. Go to Desmos, so you can just either use there might be a link in the ebook, or just desmos.com, and then you'll click on the start graphing. Type it in and just see what your graph looks like and make a sketch of it. It doesn't mean you don't need a table, but I'm gonna want you to identify where the asymptotes are, and you should be able to see those in your graph. Just because we, like again, once we graph this, we can see that it never hit 7 there. So that's what you're doing right now. I'm gonna give you maybe 3 to 5 minutes. If you have a question, type it in the chat. You can type to me directly or to everyone if you think it's a question that other people might be interested in. So again, pick a number for h, whatever you want, and then see what your graph looks like and try to figure out where the asymptotes are, because we're just gonna look for patterns there. Okay, so does somebody want to tell me what number they used and where their asymptotes are? Does anyone feel confident enough at this point to kind of give it a shot? And if you make a mistake, that's okay. That's how we're all learning. If not, I can just do a few, but it'll take a little bit longer.
I used -5. And my asymptotes were x equals -5 and y equals 0.
Thank you. So so right here, we're just gonna put a few up here. So h equals -5. So our asymptotes are at -5 and, x equals -5 and 0. So I'm just gonna scale this. So if this is -5, I think your graph should look just kind of the overall shape. Again, this is just a sketch, so it just needs to show us the overall shape and any important points. We can see we have that asymptote, and we can also kind of tell that it has this horizontal asymptote there. So our equation here, I should have written that, sorry, is f of x equals 1 over x plus 5. Anyone else have one they want to share? We're going to put 3 more on here. Yeah, go ahead.
My h value was -4, and my asymptotes were what's it called? Y equals -4 and x equals 0. Or is it? Did I have that backwards? I might have had that backwards.
Yeah, those are backwards.
Okay.
So x equals -4 and y equals 0 because. Yeah. So here, that's -4. And then remember to kind of, while you guys are kind of getting, you should have at least 2 on your paper besides the one that you did. You don't necessarily have to put all of these unless it helps you see the pattern. Here the domain is x doesn't equal -5, and the range is y doesn't equal 0. Here the domain is x doesn't equal -4, and the range is y doesn't equal 0. We'll just do if h is 3. Our equation would be f of x equals 1 over x minus 3. Our asymptotes are x equals 3 and y equals 0. And then same thing with our domain is x doesn't equal 3 and y doesn't equal 0. The other one I want to do is what if h equals 0? So if h equals 0, our equation is just f of x equals 1 over x. So asymptotes, all of these have 2 asymptotes. All of these have had an asymptote at y equals 0, so this is going to be the same. But our horizontal asymptote is also going to be at x equals 0. So this one would just have asymptotes at both of the axes. So any of these equations that are in the form 1 over x plus or minus a number, they're going to look like this. They're going to have the 2 pieces. They're going to have the 2 asymptotes. And then the domain and range are always going to correspond to those asymptotes. So for problem 32, it's f of x equals 1 over x plus 25. Can you guys see my paper still or the book?
paper.
Thank you, Ethan. Okay, so sketch this graph. What do you think it's going to look like? Look at this equation and all of these equations we just did. See a pattern. What would the H value have been? So don't say it out loud yet. Try to take, I'll give people some time to think, but see if you can just sketch this graph. And it's just a sketch. Notice how I did these, and I should have labeled that as 3 there.
That's a plus 25 or minus 25?
Plus.
Oh, plus.
That's a plus. Okay, so where are our asymptotes here? So we're gonna have an x equals and a y equals. The y equals should be the easier one, hopefully. Oops, sorry. All of these are at y equals what?
0.
0. So we have this horizontal asymptote at y equals 0. Where's our x asymptote, our vertical one?
-25.
-25. So basically, if we just say, I just say that's -25, we're going to have an asymptote there. Because if I plug in -25 into my equation, I get 0. Basically, in my denominator, it's whatever makes my denominator 0. So this graph is going to do the same thing. So basically for this problem, it would have been that we had h is equal to -25. So anytime we have an equation in this form, you should be able to identify, make a quick sketch of it and kind of identify the asymptote and then the domain and range, because again, they go together. X can't be -25 and Y can't be 0. If it's an asymptote, it doesn't hit those lines, and so it's not part of our domain and range. So that's the last part of our book work for today. We are going to take notes on quadratic equations. I think you had some in your homework last night or maybe tonight. So leave that there for a second. I'm going to try to remember to highlight the titles of my notes to kind of make them stand out a little bit different, so you can see where they separate. So what we're going to do here, and this should be review, is solve x squared minus 2x minus 24 equals 0, 3 different ways. So if we do it 3 different ways, we should get the same answer each time. So the first way is factor and the 0 product property. That's the first thing we learned, first way we learned back in math too. So factor, remember you break it into pieces, and 0, or break it into a multiplication problem. 0 product property says if you multiply 2 things together and get 0, one of them's 0. So to factor, and you may have learned factoring a little bit differently. We learned it, most of us hopefully learned it with a box and a diamond, and if you learned something differently, just let me know. So we put our first term in the upper left box, our constant diagonally from that. And then inside of our diamond, we multiply these two. So negative 24x squared goes on top of my diamond. And then the middle term, the B term, goes on the bottom of my diamond. That's a 24. Sorry, it kind of looks like a 9. So remember, the product of these diagonals have to be the same. So we're looking for 2 numbers here that multiply to negative 24 and add up to negative 2. So we're going to have negative 6x and 4x. And it doesn't matter which one goes where. The negative 6x and 4x go inside of the boxes. So remember, these have the same product there. What we were doing on our diamond, just to kind of remind you, the product is negative 24x squared, and they had to have a sum of negative 2x. Some people don't, some teachers don't teach it with the diamond and just kind of teach you these 2 pieces. So it's whatever works for you. Then we find the outside of our box. So these are x and x, negative 6 and 4. Of course. So my equation then, x squared minus 2x minus 24 equals 0, can now be written as x plus 4 times x minus 6 equals 0. So remember, 0 product property again. If you multiply 2 things together and get 0, one of them is 0. So this tells us that x plus 4 equals 0, or x minus 6 equals 0. So x is negative 4 if we subtract 4, and if we add 6 here, we get x equals 6. Any questions on factoring in the 0 product property? Okay. The second method is to complete the square. Which from my experience, this has been, tends to be people's least favorite method. Some people like it. It's all the same. So to complete the square, again, you may have been taught a little bit differently. I'm going to go over the way I teach it. And if it doesn't make sense, you're welcome to ask questions. or to kind of explain your way. So with completing the square, your x squared goes here still. And then you split your b term, your middle term, in half. Since this is -2, this would be -1x or just -x in both of these. So these have to add up to that middle number, -2, and they have to be the same. So again, I'm gonna just write my equation off to the side. The first thing I do algebraically to solve this is I move the 24 over. I isolate my x's, and I should have done that before I made my square. So we have x squared minus 2x equals 24 when you add the 24 to both sides. So basically I took this piece and I put it in my boxes. And again, my goal is to make it a square. So I have to figure out what I'm missing in this box to make a square. So if I get the, I see some people writing still, I'll give you a little more time. So if I get the outside of my box here, again, to be a square, it has to be the same on both sides. So we're missing a 1, a positive 1. Which means we now need to add 1 to both sides of our equation. By adding 1 to my equation, I have x squared minus 2x plus 1 equals 25. The reason we added 1 is so that we can write it in factored form. And the factored form is just the outside of the box. X minus 1 squared is equal to 25. These are equivalent. This is the inside of the box, and then this is the outside. So to solve this, we square root it, both sides. On this left side, what's going to happen is the squared and square roots cancel out. But on the right side, what we need to remember here is that we get plus or minus 5. Because you're asking yourself, what number when I square it gives me 25? It could be 5, it could be -5. And then this is where it splits into 2 pieces. So we have x minus 1 is equal to 5, and x minus 1 is equal to -5. So here, when we add 1, we get x equals 6. And here, when we add 1, we get x equals -4. And then our last option is the quadratic formula. So the quadratic formula, just to remind you, in case you don't remember it, is x equals -b plus or minus the square root of b squared minus 4ac, all divided by 2a. So in our equation, a is the number in front of x squared, a is 1, b is the number in front of x. So B is -2, and C would be our constant, which is -24. So when I plug these in, I have the opposite of -2 plus or minus, and I'm just going to show all the steps here. B squared, so -2 squared minus 4, it's always a 4, times 1 times -24, all divided by 2 times 1.
Mommy, can we just put my car right here?
Yeah.
Okay.
So this becomes the opposite of -2 is just 2 plus or minus the square root. -2 squared is 4. Here we have -4 times 1, so just -4 times -24, we get plus 96, all divided by 2. I recommend when you do these to try to kind of do it in steps. If a lot of people make mistakes when they plug this whole thing into their calculator, especially right here with the -2 squared. A lot of people don't put the parentheses, and then when they square it, they get -4, and it'll change your answers. So 4 plus 96, we have the square root of 100. So this is 2 plus or minus 10, all divided by 2. And so here's where you just split it into your 2 pieces. So 2 plus 10 over 2, 12 over 2, we get 6. And then 2 minus 10 over 2, -8 over 2, which is -4.